Awesome. All right. Hi, everyone. I'm Sandy. I'm a job developer here at the school. What I wanted to do was drop by your class because I know that you guys aren't on campus, but I want you to know that you still have resources available to you for free as a student. Things that you can come to me for with career services would include any sort of resumes, interview skills. If you are in electronics, but you're thinking about even going into a different program after this, within my department, we also have a counselor who can explore careers with you. If you've been in a job, I'm going to go back to the resume stuff real quick. If you're in a job currently and you're moving into electronics and you don't have transferable skills, we can help you identify those and we can build you a resume that fits your experience, as well as we'll incorporate some of the material you're learning as a student through this course, and then hopefully include some transferable skills to help better equip your resume to showcase your skills to the best of our ability when you're looking for a job. Within my department, we also put on different events. So it's just a good idea to get in touch with me now. So as you're job searching later on or anywhere in the near future, you have me as a resource. I put in email, I put in my phone number. I'm also going to add a flyer if I can. Let me see. Of a new resource that we're utilizing with the school, and it's called Handshake. And Handshake it's a little bit of a combination of like an Indeed and a LinkedIn together. And it gives you the ability to build your profile. It's made especially for college students. And every Fortune 500 companies on it. There's big and small businesses there. Employers post events. You can connect with individuals. You can ask informal questions on Handshake. And Handshake would be a place where you could put in your resume and do job searching. The cool thing that sets this apart from an Indeed or a LinkedIn and whatnot is that these employers are utilizing Handshake to scout for college students that are coming to continuing education or just pursuing an education while they're looking for work. So they have a better understanding of where you currently are. And through all the relationships we're building in San Diego, our employers will also jump into Handshake and make themselves available to you. But other than that, I'm going to try to figure out how to add the flyer in here so you can sign up for it. You would just utilize the link that I put in, and then you would log in and create an account with the same email that you used when you signed up for school. I know for some people it might be something generic like a Hotmail or Gmail. And then for those of you who had student emails created while you were becoming a student, I know that's a more recent update we've done. You could utilize that student email to log in. But let's see. Okay, cool. I'm seeing how to do this. I'm dropping the Handshake flyer in. What's cool is once you open up the flyer that I sent, you can actually even scan it to your phone, and then you can download the app there. So it's made pretty easy. Most of the big colleges around the nation are also on Handshake, so it's a great place for college and continuing ed students to be. Cool. And then I'll stop talking now so you guys can ask me questions, or if you don't want to ask now, you now have my email and my phone number, and you can reach out to me anytime.
Okay, anyone?
Okay, if you don't feel like asking a question in front of your classmates, I know it can be a little intimidating. Write down my number. That's a number, it's a Google number. You can text or call that phone number, or you can email me. I can set up one-on-one appointments. I usually work like an 8 to 5 sort of schedule, but I am flexible. So if you're someone who needs to meet after hours or on your lunch break at work, I can help accommodate your schedule with mine. And then I have ability to work with students up to a year after you leave. So I know some people might be thinking, hey, I already have a job, I'm okay right now. But just know if there comes a point where you do realize you need to update your resume or go over some interview skills or whatnot, just know that, again, I'm a free resource to you as a student here, and you can definitely take advantage of that.
Thank you.
Thank you, Sandy.
Yeah, well, thank you guys. Okay, I'll let you guys get back to your class. But again, and if you guys have students that you'd like to send me anytime, feel free.
Where are you located?
Right now I'm typically at Cesar Chavez. It's like my little touchdown base. When I'm not at Cesar Chavez in the Barrio Logan area, typically you would find me at the ECC campus, located on Ocean View Boulevard.
Oh, okay. So you're at multiple campuses.
Yeah.
Accurate? Okay.
Yeah, good question. And if you're also in another program, say you were in project management or one of the other programs that we offer at the school, there's actually a couple of us as job developers that can help you. So as you connect with me, I'd be able to help distinguish either if you stay with me or if you're going to go to someone else or visitor counselor. But we offer a lot of one-on-one support for you.
Hey, Sandy, this is Tuan.
Thank you.
You're welcome. Hey, Tuan.
Yes, I just want all the students to know that, when you go to class, you study, and eventually you get a certificate. Next thing is you go out there and look for a job. And I think this platform is one of the best platforms for you to look for a job. Getting an education, getting a certificate, a degree is one thing, but getting a job is also another. So we appreciate the school, especially Sandy come into the class and share with us. Just like she said, I have many people using the handshake platform too. When you mentioned the top 100 of Fortune 100 company, almost all of them, the top 100 biggest company in America, whether you are Walmart, whether you are CVS, whether you are Apple, whether you are Cisco, whether you are Microsoft, all of them use this platform to look for top talented, especially college students. As a matter of fact, more than 13 million college students using this platform to get a job when they get out, and this is highly recommended. So just one quick question for you, Sandy. Is it free for the student to use this platform?
Yes, it's free. You must be a college student with, we've entered everybody with the email that you signed up for school. So as long as you have that, you'll have access while you're a student, which brings up a good point when it comes to job searching. And if you guys are a demographic of students that prefer things to be virtual, there's also LinkedIn. And I know LinkedIn can also be a little overwhelming. So again, if that's something you'd like any support with, we offer workshops in that, but I can also work one-on-one to help you organize a LinkedIn account, make sure your profile is something that's going to stand out to employers and help you generate leads. Because yes, learning the hard skills, I mean, your guys' class is very difficult. There's a lot that you guys cover, and you guys are excellent instructors. So you guys can pick up all the hard skills, but knowing the soft skills when you're walking into a job interview and how you should present yourself and what employers are expecting, that's all stuff that we can help you. It's a little bit more of the easy stuff. You guys learn the hard stuff from your instructors, and we'll help you with the more soft skill stuff.
Awesome. Thank you.
Yeah, thank you, Tuan.
Do you also do practice interviews?
Yes. And if you email me, I've actually just been starting to work with an AI generated service. I think it gives you like 5 free interview attempts. But we can work one-on-one with you and do it that way. But I think this new AI feature is pretty cool. I'll have to, let me write down Anthony, can you message me privately and give me your email? You pick the industry, you write down the sort of job you're looking for, and you record your answers and it'll score you. So I think it's a really cool thing. It can be intimidating to sit in front of a person and say it, but hey, if you're just at your computer and you want to test out answers for a certain job, this new website we've been utilizing has been pretty cool. but another good question. Anybody else?
Yeah, I'm curious about counseling. So, do we make an appointment on that in Cesar Chavez, or would it be like via email with you?
I'm going to send you, if you want to talk to the career counselor, his name's Carl, and I'm going to drop his email in the chat. So it's Carl K. Cameron at sdccd.edu. He's the career counselor for the entire school. So there's general counselors that can help you with what you're doing in your program. He's going to be more of, hey, I'd like to explore potential careers or career paths, and can you help guide me? He's super knowledgeable, and he's a hard working individual, so he'd be a great person. Or you can email me and I'll connect you as well. The flyer is, are a lot of you having challenges with the opening the handshake profile flyer?
I could download it just fine.
Okay.
I'm on an iPhone, so maybe
Oh.
I can't download it there, but maybe on the computer.
Okay, if you continue to have issues, email me and I'll send it to you in another way, Vivian.
Thanks.
Cool. Okay. If you guys don't have other questions for me, I'll let you get back to class. I'm just going to stay on. I have a couple of direct message chats with you guys, but I'll just pretend I'm not here. No, I appreciate you guys so much, and I'm sorry I was a few minutes late to this.
Well, any more questions? Okay, so we will go back to the take one lecture today. Okay. Okay, hello everyone. You get before we started, you get any question to me? Okay, if it's not, first thing what I like to do, I try to review one assignment for your guy to see can we do it or not. That will be number 18. Okay, so you have to help me out to answer the question. That number 18. For number 1, what is another name for wanted follower? You're gonna have to tell me A or B or C or D.
Is it D?
D. Number 2.
A?
Hey, you look like you are very good.
No, because I haven't passed it, so I can't even submit it.
Number 3.
Is it B?
Number 4.
D.
D. Okay. Number 5.
Is it D?
D. Number 6.
D?
D, right?
Yes, D.
Yeah.
D. Yeah.
Okay, number 7.
B?
B. Number 8.
Is it C?
Let's see, one advantage of you need the gain
Mhm.
amplify over the gain of one amplifier A.
So it's not C then? Is it B?
The thing is no advantage. Number 9. Or number 8. I'm sorry. They supposed to be B. Number 9.
B?
Who else?
D.
Ideally, the voltage follower should have a what?
High is number C.
D. High input impedance
Yeah.
and low output impedance.
I
Number
thought it was
10.
low.
Okay, that's good because I had that one wrong.
Number 10. Which of the following not true of an inverting amplifier?
B.
Okay. Number 11.
Is it D?
Yeah, good. Number 12.
Because the word
C?
D was right.
To increase the bandwidth
B.
of inverting amplifier, decrease.
I thought it was B.
D. Thirteen.
I put C.
Well, if value of inverting amplifier input resistor were lower, calculate the gain.
Increase.
Fourteen.
Division D.
Point where 2 or more voltage a current meet and combine either
A.
summit 15.
B.
Perfect. $16.
A,
Perfect. Last one. 17.
A again.
Okay. Now let's see. Okay.
One.
Yes, thank you.
Yeah, the thing is, one student tried to do it, but look like still not get it done. And I can try to let you know the handout is correct. Okay. And
Unless the,
yeah, any more questions? Anything?
unless the last 9.
Okay. Perfect. Anything. Okay. You have to read over and over the handout. I don't need you guys to read the textbook. Only go through the handout over and over. That will be helping you. Okay. So now we will be going into the lecture, okay, for today.
Oh.
Okay, just a minute. Okay, now these are very important, and make sure that I have to be really understanding about the operational amplifier. Quickly go over, okay? You see this is the same symbol for the op amp. You get two input, one negative, one positive. And you have to know what the input or negative name. They name inverting input, and another one will be non-inverting input. And basically, the difference between positive and a negative input, that's what they call a VD. VD will be equal V at positive minus V at negative. And they want it to be a 0. That's only telling you one thing. Input at positive and input at negative will be equal. Okay. And that's what they really the op amp 741 IC when you're working on the level. Okay. And this is just telling you. Okay. This is the input to the op amp, and they get the input impedance. That's very, very high. They're telling you the current cannot go inside the op amp. Okay. And also, this is the gain of the op amp. And when they're going out, they get the output impedance. And they want this to be a minimum. Let input output impedance. The current coming out will be bigger. Okay. Everything they already telling you here. You have to review that. Okay. That one we already done. If anything you want me to stop it, you get the question, let me know. Okay, now they're telling you this op-amp they get you input here. Only one output instead two. That means they say this is the ended output, single-ended output. That means they're using only one out. For this one, you get to apply VE. Okay. On another one, apply a VE in another input. No big deal. However, this is a problem right here. They want to apply input to negative and apply input to positive. The important here is the signal on input 1 and input 2 must be opposite. You see this going up and this going down. Okay? This going down, this going up. That is very important. You have to pay attention on that. And also, this just telling you the offset. Okay? They make a connection to adjust the offset. What that means? For the op-amp, if the input you tie to the ground, that means 0 volt, then the output must be 0. However, maybe they not. They can be 10 millivolt or 20 millivolt. That means they get an offset voltage at the output. In order to do it, they connect the resistor to pin 1 and pin 5. Okay, then they can adjust this resistor until the output to be 0. Okay, that's what they call external potentiometer. Okay, adjust for 0 output. That means you connect the DMF at the output and try to adjust this resistor until they get 0 volt. That's what you will be working on, the level. Okay. Open loop and a closed loop amplifier. Open loop, that means you not connect anything. Okay. And we know the gain, they're supposed to be 200,000 for 741 op-amp. That's the gain built with the IC. You cannot do anything. Okay. Now, if they make the connection, then that's what they call a closed loop gain. And this will be an inverting amplifier. Why inverting? When you connect your input into the negative here, that means inverting. Input, that's what they call inverting amplifier. Okay? And now, try to understand this thing. This is 100 dB, decibel. That means a very big number for the gain. Okay? So this, at this point right here, the gain will be 100,000. And now we're talking about the bandwidth. The bandwidth means from here to here. If you're looking down, you can see you get 10 to power of 1. That means 10. And this is a frequency domain. So basically, at this time, the bandwidth only 10 hertz. That means you cannot do anything with the bandwidth only 10 hertz. Okay? So now if you want to increase the bandwidth, then the gain will be going down. I given you example. At this point, the gain now go down to 60 dB. However, the bandwidth goes up to 10 to the power 3 hertz. That means 1,000 hertz. If only one thing, I'm telling you, you want more bandwidth, and the gain will have to be lower. Okay. And now this is the circuitry we call an inverting amplifier. Basically, you don't have to memorize all of the formula or not the calculation. However, when you're looking into the circuitry, you have to know what type of the amplifier. They can be inverting amplifier, non-inverting amplifier, okay, unity amplifier, summing amplifier, anything. For this one, we call a inverting. The thing is input applied to the inverting input. That's the first thing you need to know. Then the resistor connect from the output back into input here. They call a RF. RF means the feedback resistor. Remember, when you're working in a company, you never see they put a RF on the board. In the company, they have to using R1, R2, R3, R4, R5. If they get the last ones are 50, they know in the board they get 50 resistor. So you never see the listing at the RF. However, if you see the resistor connect from the input back into output, back into the input, that's what we call RF. The other thing we have to know, we already know for the op-amp, the difference between positive and the negative input will be 0. That will be telling you V1 and the V2 will be the same. The thing is no different voltage. In this case, V1 connect to the ground. So V2 at this point also ground, 0 volt. But you see the difference. This is a tie to the ground. Physical ground. Okay? Physical ground, that means you need the wire connect to the ground. Will be 0 volt. And this also 0 volt, but it's not connect directly to the ground. That's what they get a different name. They call a virtual ground. Okay? That's a different name. Okay? And also, for the virtual ground, you can see the current go input through in when they go up to this point. First thing, they cannot go to the op-amp. We already telling you. High input impedance. They cannot slow it down. The thing is they get the same potential. Okay? So they will be go up to RF. Okay? And when they go up to the RF, and again, you understand it, they have to be positive. They have to be negative. So if it's negative here, then they have to be negative here. Okay? For the V out, you get a negative on one side, the other side have to be positive. Okay? So the current flowing here, when they go to this point, they cannot going down. Why? The thing is current cannot flowing from negative to the positive. Okay, that's what we're talking about. Conventional current. Conventional current, that means current must be flowing positive to negative. So this current is not going down and they going in. In this case, we call op-amp sync current. They put the current in. Okay, and also you get another current from the VL here. Also coming in. That will be load current. So you're adding both current, you get the op-amp current. Okay, and we already did it. We already calculate for you. However, what I want you to memorize. That means the gain. The gain for the inverting amplifier equal minus RF over RE. Okay, make sure anything confusing, stop me. Okay, so this is just the one we already did for you. Okay. Now, that one also we already did, I believe so. You get a 1 volt input here, and that's the V out. This is the load resistor 10K. They want the gain. The gain will be minus 10K over 1K. That means 10, minus 10. And if you want V out, you take V in times V, the gain. If you want the current I through R2, okay, I already telling you, you take 1 volt divide to 1K. If you want the load current, after you get the V out, and you get R5 mean R load, you take V out divide to R5. And if you want the op-amp current, you adding the current here and the current from the load. You can get that. And now, this will be applied the AC sideways. 1.2 volt peak to peak 1 kilohertz. Okay. They are this one telling me they will be 0 volt. Okay. So basically the current same thing. Only thing is they want to get the closed loop gain. That will be minus 4.5K divide 1.5K. You want to be out, then you take the gain times the input, you get the V out. However, if you see, this is the input going up, output going down. That's why they call inverting. Opposite. Okay, between input and the output. 180 degrees of phase. Okay, if they want current I through R1, you already know. You take the V in, divide to R1. Note, the input and output is inverted 180 degrees of phase. Now, next one, talking about non-inverting amplifier. Okay. Non-inverting amplifier, that's telling you how do we know non-inverting. The thing is input will be applied to positive. Okay. That's what they call non-inverting. Okay. And you looking into the circuitry, you have to recognize that is non-inverting amplifier. Next thing, have to know the gain of the non-inverting. We already proved it. However, that in here, non-inverting equal 1 plus RF divide to R1. Okay. That is first thing recognize the inverted amplifier. Second thing, if you want to calculate the gain, they will be 1 plus RF over R1. Next thing, the input applied to the op amp is not this one. They must be on this one. Okay? Connect directly to the positive. If you want the voltage here, and basically you get R2, R3, you can using the voltage divider. You get the voltage at this point. V in, that's what they call V in, equal, okay, V1 times R3 divide R2 plus R3. Okay, that means voltage follower. Okay. On this one. Okay, not inverted. They given you R2, RF, and the VE, 2.5 minus 2.5. They want to gain, you know the gain, okay? 1 plus RF divide to R2, okay? And if you want V out, you take the input times the gain. If you want to get the current through R2 right here, you understand, you know VE minus 2.5. And that will be telling you this point also minus 2.5. Why? The thing is no different between positive and negative. So whatever in positive, the same as the V1 as the negative, you can take this voltage divide to R2. You can get the current. Okay, so that's just a calculation. I think we already done it. Now, next one. Unity gain amplifier is this guy. Unity gain amplifier, only thing is unity gain, that means the gain equal 1. Okay, V out and V in will be the same. V out equal V in. They can also say this is a buffer amplifier. Okay, isolation amplifier follower. The gain equal 1. V out equal V in. Now you get another one. Configuration summary amplifier. Now this is look like inverted. Okay. However, not only one voltage applied. They get V1, V2, V3. In this case, 3 voltage applied. That's what they call summit. Okay. And the output will be equal minus V1 plus V2 plus V3 if you want the output. Next one, we're talking about slew rate. The maximum rate of change of the output voltage in response to a step input voltage is the slew rate of an op-amp. The slew rate is independent upon the high frequency response of the amplified state within the op amp. Now, that's a very simple thing. If you're looking into this circuitry, you know that unity, right? That means the gain equal to 1. Okay? So basically, when the input applied from 0 to some value here, the output supposed to be same thing. Okay? That means they can be exactly the same input here. However, they not. You see that? Take a little time. So now they can go. Okay? So that's what you know. The time from here to here, okay? They want to calculate what they call slew rate. That means they equal delta V out, the Y delta T, okay? Delta V out, that means the V out difference between, okay? Positive, negative. And delta T, that means from here to here, when they go up to normal. So, in this formula, slew rate equal delta V out divided to delta T. Now, if you want to calculate the delta V out, you take the V at the maximum minus V maximum. Okay? The unit of slew rate is volt per microsecond. Okay? That coming up with V over microsecond. This is just an example. The output of voltage of a certain op amp appear as so in the following. In response to a step input, they want to know the slew rate. Okay, solution here. The output goes from lower to upper limit in 1 microsecond. That means 90%. This is a 10% and another one. From here to here, they given you 1 microsecond. Okay, the limit are taken at the 90% point as indicated. That means in order to get the 1 microsecond, you know, first thing you have to get a 90%. Okay, of the 10 volt here, you get 9 volt. 10% of minus 10, you get minus 9. So you can get it from this point to this point. That given you a 1 microsecond. Okay, and they already get to you here. Slew rate, delta V out, delta T. That means 9 minus to minus 9. Divide 1 microsecond. Answer will be 18 volt per microsecond. Okay, and the relay problem, you guys have to take care of that. Gain, bandwidth, product. Okay, an increase in closed loop gain cause decrease in the bandwidth. You already know. I'm talking at the beginning. You want more bandwidth, then gain have to be reduced. Okay? Unity gain bandwidth equal ACL mean the gain time FC. Okay? Now, determine the bandwidth of each op amplifier. So, both of them have an open loop gain 100 dB, and unity gain bandwidth is 3 megahertz. Okay, that is a FC. That means unity gain bandwidth. For non-inverting closed loop gain, that means they calculate the non-inverting. Okay, the closed loop gain Okay, 1 plus RF over RI. Okay, that means 1 plus RF over RI. You get 67.7. FC, closed loop bandwidth, closed loop equal unity gain divide ACL. Unity gain means 3 megahertz. Okay, that's what they given you here. Divide to 67.7, you get 43.3. And you can calculate the same for this non-inverted. Okay, now they're talking about this will be in your left board. I try to help you try to understand the different amplifiers show two input circuit. You know that two input. Okay. That amplify the difference between V1 and V2. V1 is connect to inverting and V2 connect to non-inverting. When R1, R2, R4, R5, okay, 1, 2, 4, 5, equals in value, the different amplified subtract V1 and V2. That means if you want to calculate the VL in this case, VL equals V2 minus V1. Okay, in practice, the input impedance for V1 equals the ohmic value of R1. Okay, that's talking about R1. The input impedance for V2 equals the ohmic value of R2 plus R4. Okay, that means they're talking about impedance. A different amplified circuit combined the gain effect from the inverted and non-inverting resistor ratio. For V1, VL equal minus V1 times R5 divided R1. Okay. That means if you want to calculate the V1, and this supposed to be rounded, okay, that is in superposition, you cannot count both. You count one here, then this rounded. And if this is rounded, then now you get the inverted amplifier. So that's why they said VL equals V1 times gain minus R5 over R1. And now, if you want to calculate the VL for input V2, then you will be rounded this guy. That is the way to calculate it, rounded that. If you rounded that, and now V2, V out, okay, equal first thing V2, okay. But V2 here is not the one you want. You want the V right here, okay. They have to be connected to the positive. So the voltage here will be V2 times R4 divided R2 plus R4. Okay, that voltage divider. So you can see right here, R4 divide R2 plus R4. Okay, and time, okay, 1 plus, okay, R5 divide R1. This is the gain of the non-inverted. If you open the non-inverted, they will be equal 1 plus R5 divided to R1. On this part here, they calculate, make sure the voltage applied have to be at this point. Okay. Now, if V1 and V2 equal 6 volt, Vout equal. That means you get a 6 volt here, you get a 6 volt here. What Vout equal? VA means right at this point. 12 volt and VA equal 0. 0 volt and VA equal 0. 0 volt VA equal 3 volt. Tell me which one you think.
C.
Yeah, you're gonna have to tell me, okay? And I can moving on.
Someone said C.
Perfect. Now, even you not quite understand everything, however, one thing you can recognize, VA here will be equal V2 times R4 divided R2. They cannot be 0, right? So that's why number A cannot be right. B cannot be right. I think they say VA equal 0. Only C, VA will be equal 3 volt. That means they take 6 times 1 divide 1 plus 1. Okay, that is the answer. Now, in this circuit, the sideway generator apply an unwanted common mode input voltage, okay, to both circuit input due to the common mode rejection of E1. The sideway does not appear at the out. You don't know what happened, and this signal cannot be go to the output. That relate into what they call a common mode rejection ratio. That means when you get a both input V1 and V2 identical signal, they consider to be the noise. That means the signal you don't want it, and the op-amp able to cancel out, not allow that signal go into the output. That's what we're talking about, common mode rejection ratio. Okay. Common mode input voltage appear across the inverting and inverting of different amplifier across both input of a differential amplifier. LB.
Is it B?
B. Okay. They have to be both input, not either one. Now, let's see, in this different amplified circuit, resistor R1, R2, R4, R5 are much equal to each other due to the resistor value. Vout equal V2 minus V1, or the difference between the input voltage. The output voltage polarity is determined by the relation between non-inverting input voltage V2 to the inverting input voltage V1. The V2 polarity dominates the V1 polarity and determine the output voltage polarity. The following relationship apply if one is not saturated to the circuit itself. V out equal V2 minus V1. VA voltage divider, okay? And VD, that means the difference between two input equal 0. And VA equal VR4, that's correct. That means VA here, that means the input to the U1 using voltage divider. Now, in this circuitry, S1 U to switch V2 or V1 into the circuitry. That means they can connect to this side or they can connect to the other side. Okay, VL vary between 0 and plus 10 volt DC. Is essentially 0 for either F1. Vary between both A and C depending on the position of F1. The guy can tell me A or B or C or D.
B.
B,
A or B or C or D.
Someone said B.
Correct. B is correct. Why? The thing is you connect on V2. That means V2 will be the same on V1 and V2. That they will be cancelled out. Okay? If they go into the other one, the same thing. V1, V2 will be connected the same to V1. They also be cancelled out. So the answer will be B. Essentially 0 volt for either at one position. See that? That is the answer. B. The thing is when you're doing your left volt, they're asking A, B, C, D. You enter A not, you enter B not, C not, then you can get D right. However, they will be, giving you less credit on that where you pick it up. If you pick B right away, you can get higher credit. Now you see like a second time, third time, fourth time. Maybe you can get 0 credit. The different amplifier combine input waveform and the account for amplitude and the phase. You can see you get an upline to signal into V1 and V2. Okay. Output will be equal to V2 minus V1. However, they bring it up here. This input negative. And this have to be opposite. Okay. They cannot be the same. If they're the same, they consider just a noise. And they will be blocking it. Based on the circuit information, VL equal V1 equal V2 2 volt peak to peak. What VL equal?
B,
What do you think?
C. C.
It look like to me C. Okay. 0 due to common mode rejection. That's wrong. The
B.
thing is signal will be opposite. Not
I
the
think
same.
it looks like B for me.
That's the answer.
C.
Right. Now, how can we do calculation? If you want it, you have to calculate the V out with the input V1. V out with the input V1. That means you will be rounded positive.
2 minus
You're looking on, if you round it positive here, you get an inverted.
2 minus 2.
Okay, so inverting VL1 equal V1 times minus 10K divide 10K minus 1, right? That's the gain. So they will be equal minus V1. That will be time. And now you have to calculate in joule. In V2, you want to calculate, you have to suppose to round it, guys. Okay, now they inverted. You want VA right here. So VA equal V2 times 10K divide 10K plus 10K. Okay, that means VA equal a half of V2. They will be 1 volt. And now VO2. That's an inverted, non-inverted. The gain equal 1 plus, okay, minus 10K. Divide 10K, it will be minus 1. Okay, 1 plus 10K divide 10K, 1. That means joule times VA. So VO2 will be joule times VA. VA we calculate is 1 volt. Joule times 1 is joule. So basically you get VO1, okay? That means 2 volt times 1. That's what you get, 2 volt, okay? And 2 volt plus 2 volt, you get 4 volt. Okay, so basically that will be N for the operation amplifier. You get any question? Otherwise, I will be go into another one quickly, okay? Next meeting we will go more detail on that.
Barbara, I'll be right back.
Okay, I will be quickly go through decibel. That are very short, okay? And I want you, after today, you get a time try to go over. We will be going more detail on the next meeting. Okay, what is a decibel? The decibel unit important in amplifier measure. That the decibel is a measurement of the ratio of one power to another, or one voltage to another, or one current to another. That's the basic definition. They just a ratio, one power. Okay, that means P out divided to P in. Our voltage will be V out divided to V in, or the current I out divided to I in. They have to be a ratio. Okay, and they said that are very important in amplifier measurement. Power gain is expressed in a decibel dB. AP, okay, equal 10 log of AP. Now, what AP equal? A means gain, P means power. The gain will be a ratio between the out and the input. So AP equal P out. Okay, and V, AV for the voltage. V out, VE. Same thing for the current. The current will be I out divided I in. And this is the formula you must be know and try to memorize. Okay. AP equal 10 times log of AP. This is the AP in decibel. If you want to calculate the gain in the decibel, you must be using this formula. And this applies for a voltage. If you get the current, they will be the same voltage. That means 20 log of IV. 0 volt reference. The maximum gain equal a mid-range. Okay, mid-range gain and assigned to be 0 dB value. What that means for mid-range gain? That means the gain equal 1. If the gain equal to 1, that only telling you the input and the output will be the same, either power, voltage, or the current. Critical frequency. Critical frequency, they get few different names. Okay. Also known as cutoff frequency, corner frequency, break frequency. Either one, that will be a critical frequency. And now we have to know what is the critical frequency. At this frequency, output power drop to 1/2 of its mid-range. Okay, AP in dB will be equal -3 dB. Also, at the critical frequency, the output voltage is 70.7% of its mid-range, okay, AV for dB equal 20 log of 0 times log of 0.707. Also, you get minus 3 dB. Okay. If you want to calculate for the current, they still the same like you calculate for the voltage. dBm, power measurement. At unit that is often in measuring power is the dBm. The term dBm means decibel reference to 1 milliwatt of the power. When dBm is used on power measurement are relative to a reference level of milliwatt. Now, they given you the definition. dBm equal 10 times log of power divided to 1 milliwatt. Basically, to understand why we need the decibel. You never know. In reality, outside, you just know the voltage or the current, okay, or the power. Power will be in watts, milliwatt, kilowatt, megawatt. Voltage will be in volt, millivolt, kilovolt, okay? Or the current will be the same. However, the reason we have to understand the decibel, the reason is if you involve working in the RF, that means radio frequency, then the equipment using, they will be a measure in decibel. Okay? And if you get a measure in a decibel or dBm, nobody understands what the dBm. Only thing that they want to know is it a milliwatt or kilowatt, okay, or that is normal. So that's why they have to using dBm to convert it from watt to from the dBm to watt or milliwatt or kilowatt. That's the reality we have to deal. Again, what I'm saying is, when you're working with the equipment in the RF area, when they measure, they given you a dBm. They not given you watt, kilowatt, milliwatt. Now what you have to do, you have to converting that dBm into the watt, milliwatt, or kilowatt, okay? So we can understand. That is a reason we'll be telling you, you need the decibel. So you can converting whatever. Okay, they're using in the RF. Then you have to convert it into the watt, milliwatt, kilowatt, or into the volt, millivolt, kilovolt, and the current the same. That is a main thing. Okay, and especially if you apply the job to lucky get into the RF area, and I can say guarantee the job will be high paid and very, very stable. The reason is it's a very hard to training for one person to get along with working in the Yeah. Okay. Any question up to this point? Otherwise, we will be stopped the meeting now. Okay. So, if no question, and will be good night to everyone. And have a good weekend. Okay.
Good night.
Thank you,
Good night.
Professor.
Good
Thank
night.
you. Thank you. Bye bye.
Good night, Professor. Good night.
Okay. Bye bye.